So in this problem, you're actually being asked to find the cosine of 2 theta. I'm looking at number 3 here. And when you look, the picture that they have drawn is actually the cosine. Well, actually, it shows us the angle theta. It doesn't show us 2 theta. So this is actually not the triangle we're interested in. The triangle we're interested would be about twice that angle, so it would be something like this. If I'm going to draw the triangle, I've obviously got to shrink it up some. So if you look, that angle seems to be about 2 theta. And that, I'm just estimating here, but when you look at it, like, yeah, sure. So, I've got lots of information about theta, and I need to figure out about 2 theta. So when I'm looking at cosine of 2 theta, I can either realize that I can use a double angle formula, or I can realize that what this is really is the cosine of theta plus theta. So when you look at this, I'm turning something that I don't know anything about into what I do know about, which is up in here. And then so, I could use my Sinbad Coset stories, the angle addition formulas, and realize that this is the cosine of theta minus sine theta sine theta. And so if I know both cosine of theta and sine of theta, here and here, then I can figure this out. So from my picture, I can see that the cosine of theta is actually, 4 over the root of 17. And this is then 4 over the root of 17. Because that's actually the value. This is the value of cosine of theta. It's the cosine ratio. This is the value of the cosine ratio. And then I'm going to subtract. I need the sine ratio. I need to use it twice. And up in the picture there, I can see that the sine ratio is, opposite over hypotenuse. So it's going to be 1 over the root of 17. So when I do this, I'm going to get 16/17 here when I multiply my fractions. And then I'm going to get 1/17 here, which ultimately leads me to 15/17. Hope that helps.